Okay, section 7.4, how to show that events are independent. What does independent means? That the outcome of one doesn't affect the outcome of the other. Okay, so like we were doing before, if there was two events happening, the first one doesn't affect the second one, or sometimes they do affect. So if they don't affect each other, they're independent. Now they're going to go back to conditional probability. We did that back in the last book, but let me go through the first example first. Okay, so to show that two things are independent, if we can find the probability of the intersection of them, that should equal the probability of A times the probability of the other, B. Okay, so if the probability of them both happening is the same as the probability of one happening multiplied with the probability of the other, then they are independent. And I'll show you that through example. So if you take down the yellow box, if you're not sure what independent means, it did say in book 4, we did say it in book 4, take it down, that one outcome does not affect the outcome of the other. And then I'll refer back to conditional probability when we're about to do the second example. So first example. Maybe I'll turn off that light so it doesn't reflect. There we go. Right. So this is the one in the book. It says 60 students, 20 studied history, 24 studied French, 8 did history and French, and 24 neither. So I've done out the Venn diagram there. It says now investigate if the events of student studying history and a student studying French are independent. Does one affect the other? Okay. So what we want to do is find out the probability of history, find out the probability of French, and find out the probability of the intersection. So in total there's 60 people. So the probability of history is equal to, the total history is 20 out of 60. 20 out of 60, which is a third. The probability of French is equal to 24 out of 60. That simplifies down to 2/5. And the probability of both is equal to 8 out of 60, and that simplifies down to 2/15. And all you say, for them to be independent, the probability of history and French, okay, both, should equal the probability of history multiplied by the probability of French. That's how you prove its independence. You just check it out. So the probability of history and French is 2 out of 15s. So you want to check, does it equal the probability of history is 1 third, and times by 2 over 15, 2/15 does equal 2/15. They are independent. Independent. 2/15 does equal 2/15. They are independent. So all you do is find the probability of the intersection, find the probability of them separately, and when you multiply them, they should give you the probability of the intersection. So they are independent. That means if a student picks history, it doesn't affect whether they're going to pick French. Now, where that mightn't happen is, you know yourself, when you're picking different subjects, there might be an overlap where you can't do both, and picking one might affect the other. Right, second one. Now, this refers back to conditional probability. So if we look at here, they refer back to conditional probability, and they have this thing here. Okay, if you want to go back and just do a quick recap, it's in book 4 on page 210, conditional probability, and it gave us this line. This symbol is different to the slash, as in A but not B. It means the probability of A given B. You're already given B, and that is the probability of the intersection of A and B all over the probability of B. So remember, look, it said this result should be memorized as it will be used later in our study of probability. Okay, and that's what they meant, we'll use it later. So this is going to be important. So if you want to take that down again, that will help you. Okay, and then up here they showed you how to rearrange, and we're going to do that in one of the questions. So that's conditional probability. So this is example, I'll get rid of this book as well. Example 2. So it says the probability of A is 0.5, probability of B is 0.4, and the probability of A given B is 0.3. Find A intersection B. So going back to that yellow box for conditional probability, it says the probability of A given B is equal to the probability of A intersection B all over the probability of B. And we just rearrange those because we have this, we're looking for this. So this is 0.3. This is the probability of A intersection B. We don't know that yet. All over the probability of B, which is 0.4. We rearrange it, and I'll just do that up here because I'm running out of space. So the probability of A intersection B is equal to 0.3 times 0.4, and that is equal to 0.12. So the probability of A intersection B is 0.12. That's a 4 there, run out of space. I just multiply that up. Okay, so if you're ever done any conditional probability and you see A, it's not slash, that's a straight line B, that means A given B is 0.3. You can rearrange it to find A intersection B. That's again back in the previous book on chapter 5.7. And are in A and B independent? So we have now the probability of A. Doesn't matter which way you write it, but let's do it right. So the probability of A times the probability of B should equal the probability of A intersection B. So we just check that out. So the probability of A is 0.5, the probability of B is 0.4, and does that equal the probability of A intersection B, which is 0.12 we got from the last part? Okay, and that works out to be 0.2. 0.5 by 0.4 is 0.2. That does not equal 0.12, therefore A and B are not independent. Okay, so you literally just multiply the two probabilities and it should be equal to that if it's independent. They're not independent. Right, last example. Oh, here we go. Okay, it says, two ordinary fair dice, one red, one blue, are rolled at once. Find the probability of the following events. So if two dice are rolled, you draw out. Again, we did this back in third year, and the reason you do it out is just to see all the outcomes that are possible. Okay, so the red dice are done at the top, the blue dice are done on the left. It says event A is the number of the red one showing a 5 or 6. So that all the ones where the reds are showing 5 or 6 would be this lot here. All the reds shown 5 or 6. That's event A. Event B is the total of 7. So a total of 7 is this. They've done the sample space the other way around. It's fine. So a total of 7 are these lads here. Okay, so I circle them. And the reason I'm doing it out like this, so you can clearly see an overlap. And then the C is a total of 8. So it's a total of 8. Let's just get a different colour pen. Get these lads here. It says, find the probability of the following events. So the probability of the following events should be nice and easy. So we've circled them. So there's 36 altogether. So the probability of 5 or 6 on the red dice is 1, 2, 3, 4, 5, 6, 12 out of 36, which is 1/3. The probability of total of 7 is 1, 2, 3, 4, 5, 6. 6 out of 36, which is 1/6. And the probability of total of 8 is 5 out of 36. Okay, so they're fairly handy and fairly simple. Again, do it properly. Probability C equals 5 out of 36. Probability A equals probability C. That's the easy part. Now, are A and B independent? Sorry, A and B independent. That's the first one. I skipped them. Are A and B independent? So A is the red and B is the green. So the probability of A intersection B should be equal to the probability of A times the probability of B. So we know the probability of A is 1/3 and the probability of B is 1/6. So the probability of A intersection B, so that's these two, okay, is 2 out of 36. That's the only two that are common to both the task A and task B. 2 out of 36, which is 1 over 18, which is equal to 1 over 18. Therefore, A and B are independent. They equal. Okay, just hold on one second, I'll get another whiteboard. So I didn't see there was a third part. Okay, and the third part then, it says investigate are A and C independent. Okay, so that would mean that the probability of A intersection C should be equal to the probability of A times the probability of C. So we know the probability of A is 1/3 from before. So 1/3. We know the probability of C is 5/36. So we'll just simplify that out. 5 over 108. So let's see if the probability of A intersection C is the same as 5/108. So probability of A intersection C, so that's the red one overlapping with the black one, again is just 2/36, which is 1/18. Those two do not equal each other. Okay, 1/18 does not equal 5/108, so A and C are not independent. So it's actually quite easy once you get around to doing it. It's finding the probability of the intersection, the probability of the two events on their own, and multiplying them and seeing if they equal the probability of the intersection. The part that you have to go back and revise is probably conditional probability. Any questions, please ask. If you don't understand the solutions, like I think Mohammed did yesterday, ask me to go through a video. Again, you're my priority, so I'll spend the time on you lads. Okay.